Good morning, everybody. Today we're going to be graphing a sinusoidal function to fit some data, which these just mean sine or cosine functions, basically. But we're going to be taking a look at the average temperature based off the month, and then creating a sine, or in this case, a sine function to fit the data. And we're also going to hit that last piece of the vertical shift or the midline, how to find that, and where that goes in the graph. Just a quick note, I have uploaded a lot of this stuff. I uploaded, you can see over here, I've already made the scatter plot for this. If you don't remember how to do these things on your calculator, you might just Google how to do it, or you can stop by for office hours. But just to save time, I've preloaded that portion. So if you're wondering how to do that, stop by and I can show you. Or again, Google is great for this stuff. But we're looking at, again, how to fit data to this. At the very end, it asks you to do it with your graphing calculator, coming up with a sine regression line or sine regression curve that fits this. This would be one that you do by hand. So you do these when you have a hunch or are cyclical, like the year. The temperature within the year is cyclical. Winter to summer, summer to winter. It gets hot and cold predictably, so you know that it's going up and down like a sine function. And then we can fit a graph to this because of that. If we didn't know, then you might not do this process, but since we do know how years work in general, we can do it this way. But to start off, we're going to be focusing in on these two numbers for most of it. The lowest average monthly temperature and the highest monthly average temperature. They happen to be 6 months apart, which kind of just makes it nice for these functions, because it's halfway between the year or about that. So this is always a nice tame way to create a function, or a nice scenario to make a function out of it. But we'll be using these two numbers because they're the highest and the lowest. So think about the maximum and the minimum. To find, the first step when you're doing this is to find the amplitude. It's the part that plays the nicest, and the rest of it doesn't get affected by it too much. And you want to start by doing that. You want to go to your calculator and you want to find the difference between the highest and the lowest. This will tell you the distance between the maximum and the minimum. And then we want to find halfway between. We want to find halfway between that because the amplitude is the distance from the middle to either the max or the min. So we want to find this distance. If we found this distance, the amplitude is half of that. Basically 2 amplitudes divided by 2. So take your calculator. You're going to go and take 73.5, subtract 29.7, and then divide by 2. 21.9, we're going to take that, add that in here, 21.9. And then we're going to plug that into our sine function. And we're going to need these parentheses later, so I'm just going to put them in now. Probably didn't. But if you didn't want to and you just want to keep retyping it, go for it. This doesn't add anything except it makes it a little bit easier later when we start adding other things to it. But if we graph that, the only thing that should be correct between our original or our actual data in our graph is the height between the maximum, or the distance between the height and the distance between the maximum and the minimum. But we'll readjust everything else in a second. So getting out of there, our next step is going to be finding the midline. So what is the average, basically? Average temperature for the entire year. And this is our vertical shift. So that 21.9 is going to stay there. And then we're going to find the middle, or basically how much do we need to shift up to get it matching up. To do this, we just need to find the average of the two. So not the average distance, or not the halfway point between the two, but the average temperature between the two. So instead of subtracting those two values, we're going to add them. And then divide by 2. 51.6. 51.6. Change that. And this is outside of the parentheses. Make sure you are not putting it inside the parentheses. This is the portion that we haven't really done yet. So 51.6. And this, well, all this does is move it up. And because the midline is usually 0, we call this the midline because that portion also gets shifted up. But it's just the middle, basically the axis that it's cycling around. But now it should look pretty close. Now we just need to change the period and the phase shift. We're going to start by finding the period, finding that omega value. We actually know the period because it's based off of the year. And this is where you could come up with a couple different choices. Because this is the average monthly temperature and we want X to be the months, you want the period to be 12 months. So omega is 12. And because omega is 12, this value, period's 12, omega is going to be 2 pi divided by the period. So pi over 6. So pi over 6 goes here. And then plus 51.6. And it should look pretty close. We just need to then adjust it based off of the so insert pi divided by 6. The only thing we needed to do from here is to adjust where that maximum is hitting. We want the maximum to be over here, so we need to push everything to the right, or there's another maximum happening over here. We can push that one to the left. Doesn't matter which one you do. Basically just whatever you solved for, it should be there. So we're going to do that on the next screen, and I'm going to rewrite it a little differently in the graph, but I'll show you what it looks like in here. In the graph, I have that pi over 6 factored out, and this makes it so you don't have to type in pi too many times in your graph, but I'll show you what that looks like in a second. To solve for your phase shift, you want to plug in one of your points, and you really want to plug in one of these because these are what we based everything else off of. So just to keep everything tamed in nice numbers, use one of these. The prompt tells you to use January. You could use July and it'd be totally fine, but January works out really well in this case. So January was 29.7, and that equals 21.9 sine pi x minus phi plus 51.6. So 29.7 minus 51.6 is negative 21.9. Again, it works out nicely, and it should be pretty much the same process each time because you're doing very similar each time. But once you divide, you get negative 1 is sine of pi over 6 x minus phi. And then inverse trig, we haven't done a lot of it. Real quick, negative 1, sine is negative 1 at this position. And there's two routes you could take, or two logical ones. You could either go counterclockwise and have a positive angle. Later on, we will actually find out that inverse trig exists between these two quadrants. So you want to go negative pi over 2 if you're going by the book. If you didn't know that, you get a graph that works, but technically, it is this. Okay, so negative pi over 2 will get you -1 for your sine value. And then solving for, x is 1 because it's January. So I'm going to multiply by 6, divide by pi. You should get -3 is equal to 1 minus phi. I'm going to add phi and add 3. So phi is 4. And we get, just to save time, I'm going to change this to a 4 up here. This is what I'm going to type in. Y equals 21.9 sine of pi over 6 times x minus 4 plus 51.6. But if you multiply that, if you distribute the pi over 6, you get pi over 6x minus 4 pi over 6, or 2 pi over 3. So that's the technical one, but you can write it factored out in here, and it saves a little bit of typing in pi. Insert, and then we're going to subtract our phi value, which is 4 if we haven't distributed. Graph it, and it should look pretty good. This isn't going to be the perfect one. If you are using your graphing calculator's abilities, doing that sine regression like it says here, it should give you a better answer. You can go ahead and try that out on your own. It gives you the answer right here, which is pretty close to what we have, but it's not going to be as close. This is going to be closer to the rest of the data than ours. Ours are basically going to hit the lowest and the highest point, and everything else is close, but that's because it's close in nature to the sine function. This will get closer to the rest of everything. It might not go through the exact same low point and high point, but that's okay. But this is how you kind of fit to the data. This works too for perfect data, air quotes, but if it is a sine function, you could follow this strategy as well. Find the high point, low point, base everything off of that. But this is, it's nice to be able to do it with raw data too. So that's all I have for you. Ignore the worksheet portion. It's on the back of, air quotes, back of the note sheet. If you wanted to go through that, you can, but I guess until next time.